Okay, here's few more, or here are a few more examples that are kind of miscellaneous problems. And again, I addressed these when I went over the complete test, but ALEKS will give you different problems, maybe stated slightly different, and focus on certain components. And um, this here, they don't give a scenario, but they do give you a set of hypotheses. So it's kind of like they do part of the problem for you. You're not really focusing on the context of the problem or anything like that. You're just focusing on mechanics of this. And this is actually this part of this is going to be determining a p-value and also determining what the which one of these statements is true, which would be what your basically your conclusion is based on your p-value. So we get into this. The hypotheses are mu equals 5 and mu not equals 5. So that's definitely going to be a two-tailed test because of the not equals. They do give you the test statistic. Okay. So that is a 1.845. Okay. So we want to go ahead and enter that in as so. And it says, all right, now it says to shade the area represented by this p-value. Okay, so here's our test statistic, z equals 1.845. And we want to shade it, but we also, because this is not equals, we want to shade the area to the right of it and also to the left or the opposite of that. Because again, we're looking at that z statistic that I mentioned before, and extreme values in either direction. Okay, so all I have to do is pick the shading here, and I just have to pick one of these, and it's going to pop in and shade both of those. They also, I believe here, give you the p-value rounded to 3 decimal places. Okay, so we will put that in here as well. 0.065. I often forget that zero there, and it always reminds me to traditionally to put it in there, although it won't mark you wrong for doing that. Okay, so I did the first part A here, and it says, based on this, which statement is true? And notice they give us a alpha level of 0.10. So since this p-value is less than that alpha, that would be enough evidence to reject the null and conclude that the true mean is actually not equal to 5. Okay, so when I do that here, I just basically said what should the solution be down here. So definitely want to talk about the level of significance being less than that. Obviously, we would reject these two answers because it says greater than. We know 0.06 is less than 0.10. And so remember, we just need to remember that decision should be based on the p-value to reject whenever it's less than the alpha level. If it was greater than, then we would fail to reject. Okay, but in this case, that's the situation. And so we'll go ahead and check it just to double check and make sure I did everything correctly. And sure enough, we have it. Okay, so that's one using the p-value method. Now, notice there wasn't really any reason. I guess you could probably have seen that I had my template ready to go here. Wasn't necessary to do that problem. So again, they're just giving you those components and focusing on just the basic structure of what it is that you're doing here. Okay, so if I pick another one of those and introduction to performing using the critical value method, okay, which is the other method that I showed you in those other videos. Again, here's just the lead into that. And so we go ahead here and notice we're still testing a mean here, just like the last one, and they give us the hypotheses, they give us our critical values, and they also give us the value of the test statistic, okay? So based on that, they give us all this information here. Now, again, it doesn't say two-tailed test, but you need to know that not equals is a two-tailed test. And so these critical values, I got to put them in, I believe you have to put them in order here. So it's going to be negative 1.645 and positive 1.645. And our test statistic is 1.9. Okay. So I went ahead and entered all that stuff in there. Now, like I said, I did several of these examples, or I think maybe just one in that previous with one proportion z-test video. But I like how this does give the the picture here to refer to. So let's kind of talk about where this comes about, and because this is something you're going to have to do. You'll have to produce these values here. The test statistic's pretty simple. You just go ahead and punch it in, and actually you can get these from the template as well. But with that said, notice the significance level is 0.10. So what I need to do is I have to determine my rejection zone based on that. And since it is a not equals, that means I have to divide this up into two, right? Equal parts. So that would be 0.05. And I have to put 0.05 area in the right and 0.05 area in the left. So that's what this little z alpha divided by 2. So if you put in 0.10, that would be z sub 0.05. And that's negative 1.645. And the same thing over here. Okay. Just to kind of go back here, this is kind of where we were dealing with over here the other day. I think this was the first video I made or class last week. And notice if we have a significance level, two tails have to be 0.0, one tail's 0.05, and the z statistic, these are t values. We'll get into those later, but there's that 1.645 here. So that was the old-fashioned way you would have to do this, okay, before you had the template or any type of calculators and so forth, spreadsheets and so forth. So with that said, I'll get back to this. All right, so what we need to do is we don't need to find our p-value. And remember, we don't need to know the p-value as long as we know if it's either less than or greater than this value. That's all we're going to find out, okay? Number one, is it less than or equal to this value? Because if it was, the chance of that happening is pretty slim. But if it was equal or less than that, we're going to reject the null hypothesis. If it's greater than that, we're going to fail to reject. That's all we need to know to make our decision, okay? So if we look down here, my p-value would be the area to the right of my test statistic. So notice the area to the right of that is definitely less than this total blue area, all right? So technically, if I was finding the p-value, I'd find the area to the right of 1.914 and also to the left of negative 1.914, because again, this is a two-sided test. If it was one-sided, I just focus on the one tail. But it's two-sided, there we have it, okay? And so that's all I need to know. From looking at this picture, I can see my test statistic is beyond that critical value. If my test statistic was there, my p-value would be 0.10. But because it's beyond, that means that it is less than alpha, which means I'm going to go ahead and reject the null hypothesis, okay? So they ask some questions here. It says the value of the test statistic. It does lie in the region, right? It's in that blue region. So we'll select that. And therefore, we need to reject that. Because again, if it's in the region here, this is just another way of saying what I just described. That means the p-value is less than the level of significance. So we're going to go ahead and click reject. And there you have it. Okay. So that is an introduction using this critical value method. All right. I think there was one more I wanted to do here, just to throw in another type of problem. And I think it's this one here. This one's a little bit more involved. So we'll have at this. And I'm just looking here. Most of these other ones here I'll get to next class period. So let me go ahead and do this one here, and then that'll be it. And we'll have some good examples here to help you through this assignment. Okay. I'm going to look at this one real long, but it says it's scratch work down here. So we're going to kind of come up here and mess around with some stuff, and we may take a look at our template also when I'm looking at this here just to see. But anyway, let's get started here. So research is going to perform a left-tailed hypothesis test. Okay, so that would mean, the alternative would mean the parameter is less than whatever that number is for the null. Okay, and remember, you talk about these being objective tests, meaning we either reject or not reject based on the number, but really there is some degree of subjectivity because these significance levels can vary. Okay, and typically anymore in research, we really don't focus on these. This was more for ease of calculation using, lack of technology, I should say. And so, these are somewhat subjective or arbitrary. It's like, okay, well, obviously small p values, right, would indicate we'd need a bigger difference, right? If you look at those test statistics from that we were looking at, earlier. I don't know if I could pull. Yeah, here's one. The test statistic where we have z equals p minus p hat. The bigger those values are for z, right, the bigger the difference here, the larger this is going to be, whether it's positive or negative. Okay. And so what that's going to do is then as you get further and further from zero, which is the center of the z distribution, you're going to get a smaller p-value. Okay. And so, this is our criteria to reject. So the lower the p-value, the more evidence we need. In other words, the bigger the difference has to be between those, right? So, which one do you pick? Well, again, we talked a little bit, your Professor Springer should talk about type 1 errors. This is basically determining the probability of the type 1 error, right? If if the null's true and you get something out in that zone, there's less than a 1% chance. Okay, so you can reject it. You're going to reject when you get less than 1%, but the null's still true. That calculation is based on the null being true. So it's kind of like, well, I'm willing to accept that 1% chance of rejecting the null when it's true. This is just a way of interpreting this. This is say, hey, there's a 5% chance I'm willing to take to reject the null when it's true. Okay, and then there's a 10% chance. So you can see that the larger those percentages get, the smaller the difference here would have to be. And to get here down to 0.01, these differences have to be bigger, okay, between the statistic and the parameter, okay? And so that's kind of the thinking here, or the overview of how this applies. All right. So what we need to do is find critical values for these values here. Okay, 0.01, 0.05, and 0.10. All right. So that's not that difficult. We can, like I said, actually an easy way to do it would be to go ahead and look at this table here. Okay. So, and I'll show you how to get these off the template as well. But because this is a left tail, okay, we're going to be dealing with the area to the left, which means the z is going to be negative. And so if I want 0.01 to be in my left tail, that z statistic then is going to be 2.326. Okay, so I'm going to go ahead and type that in, negative 2.326. If it is 5%, okay, I'd have to kind of go over here. That would be this column. That's going to be the 1.645. Okay, so obviously that's going to be negative. And then lastly, if I want 10% in that tail, okay, so that would be this one here, right? 10% in the tail. Okay, I drop straight down. That's 1.282. 1.282. All right, so that's what I have here. So, again, you could see that this would be a one-tailed test. I guess it's scratch work here. Just enter these critical values. Let me type in the first one, negative 2.32. Six. Okay, there we go. And we're going to put our test statistic in there, which is negative 2.416. So if I typed all those in, this is just going to give us a visual here. And you could see right here that value for my test statistic, Z, negative 2.416, is less than 0.01, right? I don't know what it is, but it'd be the area to the left of that. And the area to the left of this tail right here is going to be 0.01, okay? So when I do that, then obviously this asks me now, choose all that apply. After choosing the level of significance, takes a sample and finds that for which values would the null hypothesis not be rejected, okay? Well, at 0.01, I'm rejected, right? Okay, so I'm not going to click that box. But if I go over here and I put in now my other significant or other critical value, which has a 0.05, so I'm going to go ahead and type in negative 1.6, should be 1.645. I just forgot to do that, or I didn't hit the key hard enough. So, okay, negative 1.645. Okay, so I'm going to go ahead and key that in, and notice now you can see what's happening here is that, hey, if it's, and we probably didn't even need to do that, but if it's going to be less than 0.01, it's definitely going to be less than 0.05. So again, that's going to tell me to reject it. Okay, so so I'm going to choose. I'm not rejecting here. I wouldn't pick 0.05 because if alpha was 0.05, I would be rejecting. And I think there's no sense of putting the other one in there because the area is just going to get bigger and that's still going to be less, which would mean we would reject it. So that would tell me that I'm going to pick none of those. Okay. Now, other problems, may have something that, this falls, to the left of one critical value, but not the other ones. And you have to mess around with that. But I wouldn't pick these. Now, if this, let's say my Z was negative 1.3. Well, then, yeah, I would fail to reject it at this particular value of 0.05. Okay. But, again, none of these fall to the right. They're all within the rejection region, which means I'm going to reject. And that means there's none of these scenarios where I'm going to not reject. Okay. So I know that gets a little wordy there. You may have to rewind the video there. But anyway, let me go ahead and check this out. So this is just kind of your exploration, and those would be the correct results. Okay, so there are those values there. Like I said, I already kind of showed you this, I think, on the other video, but I'll just jump right in here to, how we find that critical value. And let's see, I think I did that on the normal calculator. Was it, or no, maybe it was the proportion template. I think I did it over here. Okay. Where I think we were going with this confidence level. Like this was kind of the way of doing that. And here's this critical value, right, for 90%. So if 0.505 was in one tail, there's my 1.645. Let me go back here. If I wanted 1%, right, and this was a left tail, so or let's go with 5%. Let's say alpha was 5%. Okay, so this is a left tail test, so I would want 5% in the tail, which would mean 5% in the left, 5% in the right, which means 90 in the middle. that would apply here. Okay. All right. But what if it was 1%? Okay. So how do I get this negative 2.3? Well, what I would do is I would break up the confidence level, right? If it was 1%, okay, in the left and 1% in the right, then that means how much is in the middle? Well, that would be 0.98. Okay. And if you do that, here's your negative or 2.326, which is again what we got here. Okay. So you kind of like got to think your way through this. We don't, if we have that picture here to deal with here, again, we're just dealing with a left tail test. If it was a double tail test, again, we would have to accommodate for that. I'll just show you this again here. If we have 10% in the left, 10% in the right, we would have 80% in the middle, right? But in this case here, since this is a one-sided test, right, we are going to jump 10% in the left tail. So again, that would put 10% in the right tail and 80% in the middle. So if I just again punch in here 0.80, and just 0.8 ought to suffice for that. And here is my negative 1.282. And here's my 1.28, and that rounds to 1.282. Okay, so that's how you use your template here to do that. There may be another place in here. Again, like I said, I like this template. It's pretty slick, for doing the things that you need to do. There's a thing I don't like about stuff like this, though, is it just gives all numbers, and you've got to kind of know what cell to look in. And that's what's so nice about having these types of tools to work with here. And, again, there's a lot to be said for these old-fashioned ways of doing these, and finding these out on these tables as well. Okay. And I don't want to overwhelm you here, but there's also, again, a way of using the calculator here too. Maybe I'll just do one of these. So, again, if I put the 0.01 in the tail, notice I'm going to have Z here. And I believe this is for the right area. So if I put in, let me just see here, 0.99, hit enter. Yeah, okay. So I put, let me just type that in again so you see that. So if I want 1%, like I said in the left tail, that means, whoop, I want 99 over here on the right. So this little subscript here has to be the area right. So the left tail is 0.01. That means the right tail is 0.99. And I just hit my enter key. And there we have that as well. Okay. So I'm not trying to confuse you here. I know, like I said, it's an expectation for you to know how to use Excel. However, there are other methods available, and there's also graphing calculator methods and other statistical software. And obviously this is ALEKS's own built-in software, okay? So that's how you do this one, and how levels of significance. Again, the big picture thing is, again, I don't want you to lose sight, is that these levels of significance are indeed subjective, okay? And you have to pick one, or the researcher picks one. And typically for you, as being a statistics student, it's given to you, okay? But a researcher would have to kind of go through this, and it's kind of like, well, what type of error are we willing to make? If the consequences aren't that big, it's not a big deal, but maybe it's like, well, this medication, we want to show, if it was like P is the percentage of people that experience side effects. Okay. Let's say it's like, I don't know, 3% of the people. Well, if we can lower that, you would all agree that would be, have another medication have a lower percentage of side effects. That would be great, right? And we might set up, a null hypothesis being P equals 0.03. That's the old standard. That's what it is. And we're looking for an effect of P being less than 0.03. Okay. So the idea is, but the other factor is that this second drug is very expensive. Okay, so we want to make sure, be pretty certain before we spend all this money on it, that it actually does lower the incidence of side effects. And so what we would do then in that case, we would want to have some pretty convincing evidence. Okay, we wouldn't, in other words, we wouldn't want to reject and conclude the alternative is true, that it's actually more effective, given that it really isn't. It's still 0.03, the new medication. So we would then, in that case, set a standard here and maybe pick an alpha of 0.01. Okay, because we want that probability of making that mistake of saying, if we reject, we're saying this new medication is more effective, right, in terms of have a less occurrence of side effects. So that would be much better for us. Okay, to like I said before, we want to be certain or close to certain as we can. We're not going to be certain, but as close to certain as we can. Why is that? Because, well, we're going to be dumping a lot of much more money into manufacturing this drug and producing it, and whatever goes into getting it out of the market. So that's the issue there. Okay. So if the consequence of making a type 1 error is grave, then we're going to want a low p-value in order to reject that null. If it's not that grave, and we're just looking for something, like I said, and there's not a bad consequence for making a type 1 error, then maybe we subjectively pick a 0.10. That's why usually we just report the p-value and let the researchers, or the consumer of the research decide, is that enough evidence? And that's kind of where hopefully you'll get out of this and know that low p-values do in fact support that alternative hypothesis. Okay, the lower the p-value, the more evidence you have. So, all right, I'm starting to ramble a little bit here, but that's that for additional examples. That's kind of a little FYI. And at the end there, to enhance some of the stuff that you're doing here, maybe make it a little bit more meaningful. So I'm going to wrap this up, and I'll post this video as well. And like I said, I will see you guys on Thursday, and God bless you, and look forward to seeing you then.